here we go. This is SCON register of 8051 microcontroller. And as I explained in the previous video, these are the two flags. Regarding these two flags, we have discussed in detail. And regarding this flag, we have also discussed. And this session or this presentation is about rest of the flags. So as I said, just we have a quick recap of the previous part 1. It will take either 0 or 1, I said. Similarly, here also 0 or 1 it will take. Okay. So when both are 0, 0, we will get mode 0. Okay. When one is 0 and other one is 1, we will get mode 1. When it is 1, 0, we will get mode 2. When it is 1, 1, we will get mode 3. Right? So hope you can recollect it from the hyperlink which is coming on the top of this video. Okay. So now we will move to this SM2. Here also there are two options. Either we can put 0 or we can put 1. So if I put 0, then the multiprocessor communication mode is disabled. That means it cannot transmit. One microcontroller can transmit only to other microcontroller, but one microcontroller cannot transmit to many other microcontrollers. Okay. So we are not touching this right now. So let me erase this and then we will continue with today's presentation. So coming to REN. REN stands for receive enable. Okay. So what is REN stands for is receive enable. Okay. It is reception enabled. Data reception will be enabled if I put 1 in this. If I put 0, then the data reception is disabled. Okay. Then coming to TB8 and RB8, these are the actual original buffers where the data will be stored. Actually, the data, whatever I want to send, say for example, if I want to send capital A, its ASCII value will be 40. If I am not wrong, 40 hexadecimal number. Okay. So, but in the program, whatever we are going to write, so whatever the 4 looks like is 0100, and then 0 is 0000. So this we will start with a 0 bit and we will stop with 1. So the clock diagram, if you see it clearly, it looks like this. First 0. Okay. So then second also 0. Sorry. I hope you understand. The first bit is up to here 0, then second bit is 0, and then third bit is 1. Okay. Then rest of the all other bits are 0, and final bit is 1. So this is called start bit and stop bit. Okay. So the original data, whatever we want to transmit, capital A or capital H or small a, will be encapsulated between these two, start and stop bit. Always start bit is low, logic low signal, that is 0, and stop bit is logic high signal, that is 1. Okay. So hope this is also clear for you. And whatever the data which we want to transmit, it will be kept first in TB8. Okay. So from TB8, the receiving side microcontrollers, RB8 will receive the data. Okay. So who will indicate this for us is the SBUF register. Okay. So serial buffer register. And this is the only one register available for both transmission and data reception. So both transmission and reception cannot happen at a time. That means these are not mutually exclusive events. Okay, so we will get either transmit interrupt or receive interrupt only, but both cannot enable at a time. So we will call this TI and RI together as serial interrupts, SI. Okay, so I will write it here. Serial interrupts, SI. Okay, now then we will start how to write a small program using embedded C language. Actually, what is the difference between embedded C language and C language is I explained it in the previous video. You can go through that video once again. And now coming to the how to transmit a message and what are the things we require, how we will write a program. So first we have to start with main method because it's a C language. Okay. But above this main method, we have to include a header file, right? If it is a normal C program, we will add stdio.h. Standard input output is the header file there. But here we are writing program for 8051, right? So 8051.h. I will also show in the simulation part how this header file looks like. In that each and every register will be having some address. We can open it and we can also see it at the time of building the program. I mean compiling the program. So this is hash include 8051.h. Don't worry about the my handwriting. I will show a clear program which is written in the software. So then we have to open and we have to close this main method. And in between this, we have to do some declaration like we have to write capital SCON is equal to some 0x40. Okay, what is 0x40 indicates? If you look at the SCON register, if I write 40, then it will be like 0, SM0 will be 0, and then SM1 will be 1, and the rest of the two other bits are 0, 0. And these all other bits will be by default 0, 0 only. Okay, because we are writing SCON is equal to 0x40. That means we are enabling only data transmission, but data reception is disabled here. So instead of that, if you want to write a program differently, then how you can do that is we have to take again 0, 1 plus 0, 1. That means how much this number will become? This number will become 50 now. Okay. So 2 to the power of 0 into 1, it is 1 plus here this is 2 to the power of uh, sorry 8421. We have to write here like the logic is 8421. So the wherever 1 is there, that will be 4 plus this will be 1 5. So this will become SCON is equal to 5h 0x 50. If we write in assembly language, we have to write 50h, but we are writing in C language here, right? So we have to include 0x before the number. And you always remember that we have to write registers in capital letters only, otherwise we will get an error. I will also show you that in the simulation part. So here what happened if I write SCON is equal to 0x40, only data transmission is enabled. So we will go with the same program. And this is only this declaration is not sufficient. And here I forgot to put semicolon. So we have to terminate every statement in the C language program, right? So let me do that now. Where is the cursor? Let me check where is the cursor now. Yeah, here it is. So we have to put like this semicolon, I mean termination. Then we have to select a timer, and timer will be selected by using a register called tmod, which I already kept in my 8051 programming playlist. You can go through that. It will be also having same 8 flags, like how SCON is there. Same there also we have 8 flags. The first flag will be gate bit. Second flag will be C by T bar, and third one and fourth one will be M1, M0. Okay. Similarly, rest of the 4 other flags will be the same. So it's very easy to learn Tmod. So the second statement what we will write here is Tmod is equal to capital T M O D. Tmod is equal to, we have to write it as 0x20. Okay. So by selecting this 20, what happens in Tmod is, first I said gate bit, that is 0, and next also 0, next 1, next 0. So 8, 4, 2, 1. So we have selected only 2 here, and other 4 bits we will put 0, 0, 0. So this will become 0x20. So that's the meaning of each and every statement. You have to understand it thoroughly or clearly. Then only you can able to write the program. And these installation steps are all common for all programs, both for transmission of single character, transmission of group of characters, and transmission uh, and for reception also same. So there is a algorithm, step by step procedure for this. So in that they are mentioned these 4 initializations are must. Then the next, we have selected a serial data mode here. We have selected a timer 1. Timer 1 in mode 2 is selected, which is called 8-bit auto reload mode. There is advantage in 8-bit auto reload mode. That also you can learn from my uh, timer modes of operation video. And here serial data mode 1 is selected. Okay. So which is a full duplex USA UART mode, or 8-bit UART mode. So then we have to set the baud rate. This baud rate can be set by using the formula TH timer 1 high. TH1 means timer 1 high. Okay, T stands for timer, H stands for high, and this 1 stands for timer 1. If it is timer 0, then we have to write TH0. But timer 1 high only will set the baud rate. So this, let me select a default baud rate. I will tell you what value you have to keep it here. For which value you will get how much baud rate, I will tell you in another video. So in this video, it will become lengthy otherwise. Then the next last step is we have to start the timer. TR1 is equal to 1 will start the timer. Okay. So we have selected a timer, we have set the baud rate, and we have started the timer. Here it is baud rate is selected, and timer started. Okay, timer 1 started especially. So this TR1 is called timer 1 run control bit. Then we have to write a while 1 loop here. After this statement, we have to write a while 1, and then in that while 1, you have to write your desired sbuff. I mean, you have to put the desired letter sbuff is equal to some capital H or small h in single quotes. Okay, I will write it separately here otherwise, because the space is not sufficient. It is not fitting in this. So let us extend this arrow. I mean, this main method we will close it later. Similarly, this also we will close it later. So I hope here it is. I can understand that my writing is not clear, but while 1 is selected here, right? Otherwise, I will again write it. So this is the step for selection of the timer 1. Okay. So timer 1 is selected here. Then let us remove this. and then let us select the pen again. Here we will write while 1. While 1 is a statement which is always true. Okay. While 1 is a statement which indicates always true. So in this while 1 method, whatever you keep it, it will run continuously. So I want to transmit H, capital H letter continuously. So I will put that capital H in serial buffer register. Okay. Like this, you have to write. SBUF is equal to capital H indicates that the data is now ready for transmission. The ASCII value of capital H is encapsulated in a start bit and stop bit. Okay. Then we have to check timer 1 interrupt. If the timer 1 interrupt occurs while Ti equal to 0, you have to wait there only. Sir, why you are putting for a uh, while while loop does not require semicolon, right? But why you have kept it here means uh, I have to wait here for some time until this Ti becomes 0. I mean, until this Ti becomes 1, then only it indicates that the data is successfully transmitted. I will show this in the step-by-step execution of the program in the simulation part. But for now, you just assume that until Ti becomes 1, we have to wait here only. Then immediately you have to clear Ti. Ti equal to 0. Okay. So this completes this while method, and this completes entire main method. So this is a simple program to transmit a character, single character H. And same steps holds good for the reception also. I will write that reception program here. Main hash include reg. This same step you can copy here. Hash include reg 8051.h or reg 51.h. Even both will work fine for us. Register 51.h or 8051.h. Then in the main method, we have to copy the same steps. This SCON is equal to, you have to write 50H now because we want data reception. Okay. So capital SCON is equal to 0x50. Terminate it. Then we have to select timer, right? So first let's select timer mode of operation. So we have selected timer 1 in mode 2. Same step. Then we have to select the baud rate. At what rate the data has to be received. So here it is also, we can write 0x FD. As I promised, I will tell you how to set the baud rates, whether it is 9600 or 4800 or 2400, like that. For each one, we have a value. Or simply you can put directly -3 also here. Okay. FF -1 is FE, but there is no baud rate for FE. Similarly, like that, we have FD. So we have to start from FA, FD, and something one tabular column is there. I will show that to you later in the next video. But right now you remember that we can set the baud rate by using timer 1 high, same like in the serial transmission program, how we have set. And here also we have to start the timer. To start the timer, we have to start timer 1 run control bit, and we have to terminate the statement, same like here. Okay. And again, we have to take a while 1 loop. We have to again take a while one loop. Cursor. Okay. Sorry for the delay. I am unable to find the cursor on the screen. Here it is. Okay. So let us go to here. While one, open the bracket, and this time data is received in SBUF register. Okay. Earlier we have to keep the data, whatever that we want to transmit into SBUF register. But this time nobody is going to send us. If somebody send it, then it will be received into SBUF. Then immediately we have to copy that data into a convenient register or convenient port. So I have copied that data which is received into SBUF in P1. But before that, we have to again check here one more statement, that is while Ri equal to 0, otherwise simply wait there only. Okay. So when Ri equal to 0, while capital Ri equal to 0, we have to simply wait there only. If it becomes 1, it indicates that data is received into SBUF. So this statement we have to write on the top, and this statement you have to write on the down. Okay. So when Ri equal to 0 indicates that data is received into SBUF. So that data we have to keep it in a safe place, P1. Otherwise, it will be overwritten. Say for example, if I want to write HANU7, first H will be received, and then it will be overwritten by A, then by N, then by U, then by 7. So that should not happen, means we have to write program like this only. So we have to wait until the received interrupt becomes 1, then it indicates that data is received successfully, and then to receive another character we have to reset Ri. When while Ri equal to 1, we have to wait there only until Ri becomes 1, we have to wait there only, then immediately we have to make it 0 to receive the next character. So that's the only change in the program when compared to the data transmission. Okay, like this you have to write a program. I hope this is very clear. I mean, the concept is clear, but my handwriting is not clear. I understand that. Okay, so you have to bear with me. But the if you listen it, then you can write it also on your own. So first we have to start with header file, which is hash include reg51.h or 8051.h. Then we have to start again a main method. We have to open main method, and immediately we have to start initialization of SCON register with either 40 or 50. 40 is enough for transmission. 50 is compulsory for data reception, because REN will become 1 in 50. And timer mode selection we have to do. We have to select timer 1 in mode 2. Then we have to set the baud rate. Then we have to start the timer 1, because we have selected timer 1 in mode 2. So timer 1 run control bit only we have to make it 1. Then the timer starts. Okay. If the timer starts, it starts from 00, it will become 01, it will become 02. Like that, it will continue up to FF. Then the timer overflows to again 00. Okay. So that all the concepts you can learn it from timer modes of operation. A separate video is there in my playlist. And coming to the next, we have to open a while one loop, which is always true. Then in the while one loop, we have to put our desired character, which is H, I want to transmit, and we have to wait until that transmit interrupt flag becomes 1. So we have to write while Ti, capital Ti equal to 1, then immediately we have to make capital Ti to 0. Close the while loop and close the main method. And here also same. Let me take a black pen. So main here also header file we have to include same header file, same steps. The first 5 steps. Main method, of course, main method is very important in all C programs. In the main method, first 4 steps are common. Okay. So we have to select SCON, we have to select tmod, we have to set the baud rate, and we have to start the timer. Then in while one loop, instead of writing sbuff is equal to h, we don't know what characters we are going to receive, right? So we have to check for this while loop. While ri equal to becomes when ri becomes 1, that you can check like this. While ri equal to 1, while ri equal to double equal to 1. Okay, so that double equal to 1 indicates we have to check whether it is becoming 0 or 1. So initially it will be 0. So whenever it becomes 1, it transmits data into sbuff. So that sbuff, whatever the data is received into sbuff, we have to keep it in P1. Okay, so as I said that this statement should come up and the P1 statement should come down. Then immediately you have to clear Ri equal to 0. I wrote only R here, so but it is Ri. Okay, capital Ri. Always you have to write registers in capital. Okay, so now we will switch to simulation part.